So, good afternoon, guys. Welcome to NEET World Institute and NEET World YouTube channel. And yeah, as you know that this class and this series is about only for the EAPCET, right? Aspirants in both medical as well as NEET. I mean medical as well as engineering terms, right? No, yes. So in up to last class we were discussing about the chapters like units and dimensions, measurements and errors, motion in a straight line, motion in a plane, then laws of motion, right? So these are the chapters we were discussed, and we were discussing about the EAPCET questions in each chapters, and we are going next topic is called work, energy and power, right? Yes. So let's wait for 1 or 2 minutes. The people are joining over here, right? Okay, so let's start the class. Right. So as I told, we are going for the topic of work, energy and power. So this is the topic which we are going to discuss in this class, right? So before that, we need to know about some basic idea of what is scalar quantity and what is vector quantity, and which we have discussed in the last class only, right? Like before planes starting only, we were discussing about what is scalar and what is vector quantity. But when we come to the chapter called work, energy and power, now we need to know about some glance of what is scalar and what is vector, right? Once again we'll see that thing and we can go into the topic, right? Wait a minute, let me arrange the camera. Sorry for the disturbance. Yeah, I guess it's clear, right? Okay. So the scalar product, right? So a vectors can be multiplied in two ways. First thing, a scalar product or a a vector product, okay, dot product or cross product will say, right? So two types of vector multiplications are available. One is a dot product and one is a cross product. This dot product is said to be scalar product and this cross product are said to be a vector product. And guys, who have not listened for the previous lectures of the scalars and vectors, no, you can take a note of this, okay, properly, right? So first we are going to see about what is a scalar product. That's the main important thing we need to discuss in this lesson. Okay. The scalar product of any two vectors is like, if I talk about a vector which is denoted by arrow mark, right? Like any variables, if I denote by this arrow mark, is called as a vector, no? Right. So two vectors is equal to the product of their magnitude and the cosine sign of the angle between them, right? So if I take a vector and b vector, right, a vector and b vector, if I do the dot product, okay, dot product, a scalar product of that, I'll get ab cos theta. So now a and b is a scalar quantity. Now ab will be a scalar quantity. When I do a like dot product of two vectors, the resultant will be a scalar. When I do a cross product, like if I talk about a vector cross b vector, the resultant will be again a vector only. But when I do a vector dot b vector, the resultant will be a scalar product. So this is the conditions we should know when we are doing a dot product or scalar product. Okay, so the condition will be like a dot b will be equals to ab cos theta, right? So like this will be depends upon the cos theta, no? Yes or no? Yes. So this is the formula for the scalar product, right? You can take a note of this and we'll go for the next one. Okay, done. So next one, properties of scalar product we need to know. So first one is a commutative property. So commutative property is nothing but, like, let me explain the thing. So a vector dot b vector, which will be equal to b vector dot a vector, which means I can say that a dot b, like a vector dot b vector will be equals to ab cos theta, right? So this also like b vector dot a vector will also give ba cos theta. I can rearrange this as ab cos theta. So these two are equal, right? So scalar product, like commutative property, will be applicable in a scalar product, which is a vector dot b vector will be equals to b vector dot a vector. Okay. So when I talk about a commutative property for a scalar, a vector, no. So it will not be equal in the vector. Products, because a dot b, or else I can say that I cross j will be equals to k, whereas j cross I will be equals to minus k. Is this equal? No, right? Yes. So whenever I talk about a commutative property in a vector product, it is not equal. Right. Next is distributive property. A dot of b plus c. I can distribute a dot b, ab and ac, right? So next is a dot of lambda times b. So I can take this lambda out, which is nothing but lambda times of a vector dot b vector, right? So this is the distributive property and the commutative property of the given things, scalar product, right? So next one, what we are going to see, unit vectors. When I talk about the unit vectors, this is the main thing when we are discussing in the problems. Like this is the important thing, right? So I dot I will give the simple thing, guys. So this is my x-axis, y-axis, z-axis. X-axis said to be I cap, y-axis said to be j cap, z-axis said to be k cap, right? When I take two vectors, like two similar vectors, equal vectors, I cap, again I cap. The angle between them is like this is my I cap initially. Again I am taking the same I cap. Angle between them will be equals to 0. Cos 0 is 1. Right. So I can say that I dot I will give 1, j dot j 1, k dot k 1. But when I talk about I dot j, angle between them is 90 degree. Cos 90 will be equals to 0. Cos 0 will be equals to 1, right? So this is the thing I need to know, right? So This is I cap and this is minus I cap. No, angle between them is 180 degree. So cos 180 degree will be equals to minus 1. That's it. So I dot I 1, j dot j 1, k dot k is 1, but whereas I dot minus I will be minus 1, j dot minus j will be minus 1, k dot minus k will be minus 1. Okay, so this is the unit vectors of the scalar products. Okay, so let's discuss what will be the unit vector of the vector products. Okay, so that you will have some idea about how it will be different. Okay, so A vector cross B vector will be AB sin theta, right? AB sin theta, and I have told that A vector cross B vector is not equals to B vector cross A vector. It is not equal. Okay, and let me discuss that in a graph, that is unit vectors. This is my x-axis, z-axis, and this is y-axis. X-axis, that is I cap, y-axis, that is j cap, z-axis, that is k cap. Right? So simple thing, you can keep remember that one. I, j, k. I to j, j to k, k to I. Okay, if they are asking I cross j, I cap cross j cap will give us, so I to j will give k. Okay, like this. Now next j cap cross k cap will give I cap. Okay, the thing I can remember, clockwise is positive, anti-clockwise is negative. Clockwise is positive, anti-clockwise is negative. K cap dot I cap will give j cap. Because why I am taking like this? No, one thing, I am going from I cap, like x axis to y axis. Resultant will be outward. That is positive z axis, positive k. Right? Suppose if I am going y to I, that is y axis to x axis, the resultant will be inward. Inward, no? So it will be minus k will come. So okay. So suppose j cap cross I cap will give minus k cap. I am going from j to I minus k. Reverse manner, no? So k j will give, what is that? Minus I. Yes, no? Minus I. Next, I cap cross k cap will give minus j cap. One more thing I can easily understand that ijk is the thing, right? No? If ij is there, remaining will be k. If jk is there, remaining will be I. If ki will be there, remaining will be j. That like that I can understand this. And only one thing, the sign I should get it. Either I am going front, it will be positive. If I am going back, it will be negative. That's the main thing in the vector. And when I talk about this, no, like yeah, I cap cross I cap will give 0 because this is I cap. Again, one more I cap I am keeping over here in the sense angle between them will be 0. So sine 0 degree will be equals to 0. Sine 90 degree will be equals to 1. Okay, this is the thing you should remember when you are doing for the scalar as well as the vector things. Okay, these are the unit vectors. Okay, so next one, a problem solving things. Right, so suppose a vector is given as axi cap plus ayj cap plus az k cap. For example, if I take like 2i cap plus 3j cap plus 4k cap, like this. Okay, and b is equals to bxi cap plus byj cap plus bz k cap. What is the dot product of that? What is the dot product of a dot b? So a dot b in a sense, I can multiply this with this terms, right? So if I multiply, no, I dot like axi dot, say axi dot bxi. Okay, I can multiply. Next axi with byj. So I dot j 0, no. Then I dot k also will be 0. So I can understand here I dot I can multiply, j dot j I can multiply, k dot k I can multiply directly. Remaining things obviously it is 0. So what will be the answer? What will be the answer now? I can say from here this one. It is a vector dot b vector will be given as ax I cap bx I cap, right? So ayj and bxi will be 0 and remaining like everything will be 0. I can say that ayj cap dot byj cap plus az k cap dot bz k cap. So this is the thing I can easily remember, no? Yes. Okay. So a dot a will be equals to 0 and a and b are perpendicular to each other. A and b are perpendicular to each other. Okay, this is the note point. So perpendicular in the sense sin 90. Is it? Cos 90, right? Yes. Cos 90 degree equals to 0 because I am using a dot product. A dot b equals to ab cos theta. It's not sin theta, okay? It's a cos theta. Okay. Now, if two vectors are equal, what is the thing? Ax plus ay plus az, right? So, if they are asking the magnitude of this vector, I can take root over ax square plus ay square plus az square. And if they are asking what is the magnitude of ab, I can take the root over ax I cap dot bx I cap whole square, and similarly for j and k. Okay, this is about the problem solving techniques. Done? Can we go for the next one? Okay, fine. Now we'll come to the topic of work, right? So work is nothing but like for example what things you will say as a work. If you have done something and the things your mom told to buy something from the grocery shop, or mom told to buy something from some other shop, right? And you are going and getting and you are doing that, right? So from one place to another place you are displacing and you are applying a force on you, like right now, like forcefully they are sending you outside to buy those things, right? And you are displacing from that point to another point. So work is nothing but it's a defined as the product of component of force in the direction of the displacement and magnitude of the displacement, right? So formula is work done is equals to F dot D or F dot S or F dot X, whatever it is. So W is equals to, I can say F dot V, or W is equals to F dot S, or W is equals to F dot X. So if both are vector quantities. No, force. What is the force formula? Mass into acceleration. What is acceleration? Velocity by time. What is velocity? Displacement by time. What is displacement? Displacement is a change in position, right? No, change in position. So we'll say that displacement is a vector quantity, so velocity is a vector quantity, acceleration also vector quantity, and force also vector quantity, right? So displacement. So two vector quantities. If I do a dot product, I'll get a scalar quantity. So work done is a scalar. Okay, it's not a vector, it's a scalar product. Okay, I mean, yes, done. So W is equals to Ft cos theta, Fs cos theta, Fx cos theta. So the unit is Newton meter, I can say, or joules. Okay, and the dimensional formula means like in terms of MLT I need to get it. So ml square t power minus 2 is the dimensional formula for the work done. Okay, work done. Okay, can we go for the next one? Okay, now we will see like whether the work done is a positive, a negative, or it can be zero also. See, I'm applying a force, but it doesn't displace there. It doesn't displace. Like for example, the wall is there. Okay, I'm trying to apply a force on the wall. So what is the angle made by the force and the displacement direction? Okay, it is 90 degree, right? So cos 90 is 0. Fine. So when I talk about the angle, when I talk about the work, angle plays an important role in that. Right? Angle plays an important role in that. Right now? Yes. So positive work and negative work. So when I talk about a positive work, no, the angle should be between 0 to 90 degree. 0 to 90 degree, whereas negative work angle 90 to 180 degree. 90 to 180 degree. So negative work means like it can be a friction also, right? Like you are applying a force, but opposite direction some other heavy force is applying, right? That is, it can be opposing force also, right? No, it's a friction also we can say, right? So if angle between 0 to 90, it's a positive work, 90 to 180, negative work. So what about 0, sir? So when angle is exactly equal to 90, I can say it's a work done. It's work done equals to 0, right? Yes, you can take a note of this. We'll go for the next. Can we go for the next one? Okay, so condition for no work is done. So condition for no work is done in the sense either displacement should be 0 or force should be 0 or the angle will be perpendicular. So first condition, displacement is 0, like d is equals to 0. You are pushing hard against a rigid brick wall, right? No, so you are applying a force, like n force you are applying, but there is no displacement happening here, which means work done is equals to 0, right? Next condition is force is 0, F is equals to 0. A block moving on a smooth horizontal surface, which means it's going with some velocity, constant velocity. Force will not be there, right? No, force will not be there, and displacement happened, but there is no force, so work done will be 0. So two conditions we have got it, right? And the third condition is force and displacements are mutually perpendicular, right? Mutually perpendicular. Where we can say here this like displacement also is there, force also there, but they are perpendicular to each other. That time I can say no work is done. So I can take an example as a circular path. Okay, before that I will complete here. So theta is equals to 90 degree, cos 90 is 0. So W is equals to FD cos 90 degree. Cos 90 is 0, so work done will be 0. That's the thing. A block carried by a person. A block carried by a person. So you are applying a force like right now, and you are carrying like this, which means work done is 0. So example 2, at any instant of time, centripetal force and displacement are always perpendicular. Centripetal force in the sense the force which is towards the center of the circle, and object is moving. Like, how can I say what is the direction of the circular path? I can take a tangent, right? I can take the tangent of the circular path and I can say that this is my direction. If I talk about this point, if I take a tangent, this is my direction and force will be towards the center. So angle is perpendicular. If I take any point, the force and the displacement angle will be perpendicular, right? So work done by centripetal force is always equals to 0 only. It's always equals to 0, right? Okay, can we go for the next one? So here is the question. Find the angle between the force F is equals to 3i cap plus 4j cap minus 5k cap, and displacement D is equals to 5i cap plus 4j cap plus 3k cap. Okay, and also find what is the projection of F on D. F on D. So this is the question. Okay, so we'll discuss the answers now, right? Okay, take this question. Take down the question. Okay. See, F they have given and D they have given, no? So what is F dot D? So F dot D in the sense like I need to take this 3i cap, 5i cap, then 4j cap, 4j cap minus 5k cap plus 3k cap, right? So 3 into 5, 4 into 4 minus 5 into 3. So 15 plus 16 minus 15. So minus 15 plus 15 get cancelled off. 16 units I'll get. 16 units. Now the formula to find what is the angle is nothing but F dot D by FD. Right? F dot D by FD. Okay, let's discuss here now. Fine? Yeah. We'll do the problem. Where is the slide? Yeah. We'll take this slide only. Okay, fine. So F is equals to 3i cap plus 4j cap minus 5k cap, right? And D is equals to 5i cap plus 4j cap minus plus 3k cap, right? No? So work done is equals to F dot D, right? So to find the formula, that is to find the angle, cos theta is equals to F dot D by FD, right? So F dot D, no? So 3i cap plus 4j cap minus 5k cap dot 5i cap plus 4j cap plus 3k cap, right? So I dot I can do I dot j 0, I dot k 0, right? J dot I 0, J dot j I can do, J dot k is again 0, right? K dot I is 0, K dot j is 0, K dot k I can do, right? So answer will be 3 into 5 is 15, 4 into 4 is plus 16, minus 5 into plus 3, minus 5 plus 3, like I need to multiply, minus 15. So minus 15 plus 15, 16 units. That's the answer we got now in that case also, right? That's the thing. Now how to find f and how to find d? If I take the magnitude of this, magnitude of f in the sense root over 3 square plus 4 square plus minus 5 the whole square. So what is 3 square? 9 plus 16 plus 25. So 25 root 50. Root 50 I will get. What about d? Displacement is equals to root over 5 square plus 4 square. 4 square plus 3 square. How much? Root over 25 plus 16 plus 9, which is nothing but root 50. Root 50. So I got the values as 16, root 50 and root 50. Right. Now cos theta is equals to f dot d, f vector dot d vector by f into d. So f vector dot d vector is 16 divided by root 50 into root 50, which is nothing but 16 by 50. Right now I can multiply these two things, so I will get 50 as the answer, and this is 8 times 25 times, which is nothing but 8 by 25. Right? This is the answer. This is the answer. Yes. So we'll see some other questions also. Okay. So if I want in points also, I can do it. So 8, 25 no. So point in the sense 0, right? 0 will get. So 2 times 50, and this again 3, 0, 1, 0 I can add, 0 I can add, right? So in points also I can get the answer, right? This is the answer for the given question. So theta will be equals to cos inverse of 8 by 25. 8 by 25. Right? We can take the answers. We'll go for the next one. Okay, yes. So see, we got no. So it's 16 by root 50 into root 50. It's approximately they have given us 0.32. Yes, that same thing we also got it. Right. See, like it is 16 and this is 8. No, 8 and this is 25. 0.003 75 and again 0 I mean 5 0. So 0.32. Right now, this is the answer. So next one, what is the question? The next question was also find the projection of f on d. So f on d in the sense f dot d is 16 unit, fd cos 60. I mean fd cos theta is 16. Right, 16 because angle between them. Okay, wait. Let me explain. You will get right. Okay, no issues. See, f dot d is 16 unit. So work done is equals to f dot d also I can say, or also fd cos theta also I can say, right? Fd cos theta also. I can equate both the things now. So fd cos theta will be equals to f dot d. So what is the thing they are asking? Projection of f on d. So f cos theta will be equals to f dot d by d. Suppose if they are asking what is the projection of d on f, d cos theta will be equals to f dot d by f. Okay, this is the answer. But in this case, no answer for the both the things will be equal because root 50 only we are getting for the f and root 50 for d also. Okay, you can take a note of this. It's one of the important things. Sagar Kumar. Okay, we'll go for the next one. Okay, done. So the next question. A cyclist comes to a skidding stop in 10 meters. Cyclist comes to a skidding stop in 10 meters. During this process, the force on the cycle due to the road is 200 Newton. Due to the road is directly opposed to the motion. Directly opposed to the motion. Fine. How much work does the road do on the cycle? How much work does the cycle do on the road? Two things I need to get it. So the given things are like F is equals to 10 meter. D is equals to, F is equals to, D is equals to 10 meter. Okay, sorry guys, okay. D is equals to 10 meter and F is equals to 200 Newton. Okay. These are the given terms and two things are there asked. One is how much work does the road on the cycle? How much work does the cycle on the road? Okay, we'll see the answers. Okay, so first one, the stopping force and the displacement make an angle 180 degree. Why 180 degree? I am going in a cycle in the right direction and it's opposing me in opposite direction. Angle between them is 180 degree. So FD cos theta. So F is 200. D is 10 and cos 180 is minus 1. So minus 2000 joules. Minus 2000 joules will be the answer. Right? Okay. So the next one. Right? How much work does the cycle on the road? How much work does the cycle on the road? Cycle weight will be acting towards down and I am going in the right direction. Angle between them, like this is the force F, this is the displacement. Angle between them is 90 degree. Right? There are two forces acting on the road. Weight on the cycle is mg. Cycle at 200 Newton force on the road from the Newton's third law. Right? Yes, obviously. But the road undergoes zero displacement due to any of these forces. Any of these forces. Fine. So D is equals to 0. So work done also will be 0. Got it? Okay, so we'll discuss one more question here. Like I'll give a question over here. Do the dot products. Okay, do the dot product of that. So A is equals to 7i cap minus 5j cap plus 2k cap and B is equals to 3i cap minus k cap. This is the fission. Okay, I need a vector dot B vector answer. And what is magnitude of A and B separately? Okay, these two things I need to get now. First, okay, so we'll discuss the answer now. So A dot B they are asking, right? So what is A? 7I cap minus 5J cap plus 2K cap dot 3I cap minus K cap. So 7 and like I caps, J caps and K cap, right? The common thing I can get it, no? So 7 3s are 21 minus 5 and J is not there, 0, so it is 0 only. So 2 into minus 1 is minus 2. Answer is 19 units, right? Now magnitude of A they are asking. A will be equals to under root of 7 square plus 5 square plus 2 square. So which is nothing but 49 plus 25 plus 4. How much? 74, 78. Root 78. What about B? B is equals to root over how much? 3 square plus 1 square, which is nothing but root 9 plus 1. Root 10 is the answer. Root 10 is the answer. Okay, so this is the scalar product. Like this is how we will do the scalar products. So we will see the next topic in the upcoming session. Okay, with this we'll end this session, guys. Okay, thank you. We'll meet in the next class. Bye.